All right, we are at the end of chapter 12 about trigonometric functions, and today we're talking about inverse trigonometric functions. We've actually done a little bit of work with this previously when we've done things like if I know that the sine of theta is 1/2, I have to take the inverse sine of both sides, and that ends up giving me the angle. So in this case, theta could be 30 degrees. But we're going to kind of expand that idea in this section and talk about what inverse trig functions are, find their values, and so on. The vocabulary you need to be on the lookout for are principal values, arc sine, arc cosine, and arc tangent. All right, so when I have an inverse trigonometric function, sometimes I know the value, like when I say, okay, the sine of theta is 1/2, but I don't know the angle. The angle measure is unknown. When I don't know the angle, that's when I apply the idea of an inverse function. So back in lesson 8.8, we learned that inverse functions happen when x and y are reversed. So here in this graph, we have the basic graph of y equals the sine of x, right? And in this graph, they reversed x and y. You can see that here. Here I have x equals the sine of y. So it looks like this, which just looks like the sine graph kind of turned on its side, right? Notice that the inverse relationship here is not a function. It would not cross past the vertical line test, right? A vertical line would cross it more than once. So that inverse relationship, when I switch x and y, is not a function. So in order to make it a function, what we do is we basically restrict the values so that I only have a piece that is a function. So basically I would say like, okay, I'm only going to look at it from here to here, right? So I'm only going to look at these values, and then this piece right here between those two lines would be a function if I only look at that. And that's actually what we do. And we call the values in those restricted domains, we call them principal values, right? So if here I'm looking from negative pi over 2 to pi over 2, that means in my original function, I would only be looking from here to here, and that's what I would take the inverse of. And those values from negative pi over 2 to pi over 2 in this case would be called principal values. And we use capital letters, and I'll show you this in a second, to show the difference between trig functions with restricted domains, where I'm only looking within a certain value range, just from the basic ones or the normal ones where I can take any value. So when I look at this, here the principal values are for sine, cosine, and tangent are shown. So notice the capital S here, y equals the sine of x. That means that I'm only taking x values from negative pi over 2 to pi over 2. Cosine x with a capital C means I'm restricting my domain from 0 to pi. And for tangent, I restrict it from negative pi over 2 to pi over 2. Notice for tangent it can't equal because tangent is undefined at negative pi over 2 and pi over 2. So these are called the principal values for sine, cosine, and tangent. So if I take sine and I'm only looking at it from negative pi over 2 to pi over 2, or from negative 90 degrees to positive 90 degrees, the inverse is called the arc sine function, which also looks like sine to the negative 1, or inverse sine. So arc sine is the same as inverse sine. And its domain is from negative 1 to 1, because the range of sine, remember, is from negative 1 to 1. Its range is the same as the domain of sine, because remember in inverse functions we switch domain and range. And this is just telling me that I can take the inverse of the original function and I just get x by itself, or I can take the function of the inverse and get x by itself. So here is, you have this on your notes, arc sine can be distinguished one of two ways. Both of these mean the same thing. Its domain is from negative 1 to positive 1, including negative 1 and positive 1, and its range are the principal values of sine. Arc cosine, same thing. There are two ways to write it. Its domain is from negative 1 to 1. These are its principal values in radians and degrees. And then same with arc tangent. So remember, you need to be careful when you're thinking about this. Y equals inverse cosine of x. If I have this relationship, if x is 1/2, then y would have to be, so I'm saying the inverse cosine of 1/2, right? I'm saying, what angle gives me a cosine of 1/2? That would be 60 degrees, 300 degrees, and every coterminal angle. If I have the capital C inverse cosine, then y can only be 60 degrees because we only take the values in this range, in the range of the principal values. So let's take a look at evaluating this. I'm inverse sine, notice the capital S, so that means I'm only going to be looking at values between negative pi over 2 and pi over 2. So I'm saying, what angle gives me a sine of the square root of 2 over 2? So what angle between negative 90 degrees and positive 90 degrees gives me a sine value of square root of 2 over 2? Two ways to think about this. One is to think about the unit circle in the ordered pairs, and I know that when theta is 45 degrees, that sine is square root of 2 over 2. So inverse sine of square root of 2 over 2 is 45 degrees, or pi over 4. And another way is to use a calculator. You, of course, will have to know how to do both ways. Here they're showing you the strokes for a specific calculator, but basically you just find the inverse sine button on your calculator, and you put in square root of 2 over 2, and when it equals, it should give you 45 degrees, or if it's in radians, pi over 4. All right, if I'm going to do the same thing for arc sine, remember arc sine is the same as inverse sine. That capital A means I'm only dealing with values from negative 90 degrees to 90 degrees. It says write the angle measure in degrees and radians. They want both. So I'm looking for the angle that gives me a sine of negative 1. In this case, this is not a value that we can get from special right triangles easily, so we have to do this. Well, actually, there is a way to get it from the unit circle, but if we're doing this with the calculator, it would give us negative 90 degrees, or negative pi over 2. If you think about quadrantal angles, if I'm thinking where sine is negative 1, or where the y value is negative 1, that would be down here at the point 0, negative 1, and that value is negative 90 degrees. Okay, you guys try this one. What angle gives me a cosine of square root of 2 over 2? Remembering that in cosine, I'm going from 0 to pi. All right, you should have gotten 45 degrees or pi over 4. And part B, what angle gives me a cosine of negative 1? What is the inverse cosine of negative 1? Should be 180 degrees or pi. Again, thinking about quadrantal angles. If I think about the coordinates of this point as negative 1, 0, I know the x value is my cosine value. So what angle gives me a cosine of negative 1? 180 degrees. And remember, it has to be within that range, or that principal values of the cosine function. All right, so here we're kind of nesting trig functions within each other. Remember, anytime I have inverse cosine of a number, this represents an angle. I'm asking myself, what angle gives me a cosine of 4/7? And then that angle, I'm going to take the tangent of that angle. All right, in this case, 4/7 is not a common cosine, and so I would do this with a calculator. I would do the inverse cosine of 4 over 7 in your calculator, and we get this value. Well, no, we don't get that value. Sorry, I misspoke. You could do this all at once in your calculator. You can do tangent of, and then you plug in negative cosine, or inverse cosine of 4/7. And when you plug that in, it should give you this. So make sure you know where those buttons are so that you can plug them in correctly. So I'm saying the tangent ratio of whatever this angle is 1.44. All right, so you guys try. Make sure your calculator is in radians. Okay, you should have gotten 1.12 radians. All right, solving equations by using inverses. This is what we've done before when I'm finding an angle measure using inverses. I can rewrite trig functions to solve. So for example, they give me this equation. The cosine of theta is equal to negative 0.86. I need to find theta. So if cosine of theta is equal to this, remember I can basically take the inverse cosine of both sides. That's what I'm doing. Inverse cosine of cosine, those undo each other because they're inverses. So I end up with theta is equal to the inverse cosine. Oops, sorry, I should be writing the capital letter, and I forgot. Inverse cosine of negative 0.86. Or here, notice how they have an arc cosine. Remember, those are the same thing. And then I solve it by using a calculator because, again, 0.86 is not like an easy one that we can find with our special right triangles. So we end up with the angle being 149.3. Okay, so doing the same process, find theta in this case. Notice in degrees. All right, you should have gotten close to negative 45 degrees by taking the inverse sine or the arc sine of negative 0.707. All right, last examples here. It says a water ski ramp is 5.5 feet tall. That's what they are showing us here in this picture. And 12 feet long. So here's the length of the ramp. Write an inverse trig function that I could solve to find theta. We did this back in the first section of the chapter. I know the opposite side and the hypotenuse, so I'm going to use sine. Hopefully you drew the picture in your notes. So I take the inverse sine or the arc sine of both sides. Sorry for writing it like that. And then I'm going to use a calculator to figure that out, and I get about 27.3 degrees. It's important in these that you're paying attention to if your calculator is in radians or degrees to make sure you get the right answer. So the angle of elevation of my ramp is 27.3 degrees, approximately. All right, last one for you guys to try. All right, your answer should be B. This is what the picture should look like if you drew it out. Again, we're going to use inverse sine of 8/20 to solve for the angle. So you end up with theta equals the inverse sine of 8/20. And when you solve that, you get about 23.6 degrees. All right, that is the end of this section, and I'll see you in class to practice.